Understanding Stefan-Boltzmann law. Now this is another important law in radiation. We have already covered Wien's law, Kirchhoff's law, and Stefan-Boltzmann law is a derivative from the Planck's law. Now since we have understood the Planck's law and we have gone through the Wien's law, under the Planck's law we know that we focused on the Planck's constant, and Planck's constant multiplied by the frequency gives me the energy. However, under Wien's law we understood that the wavelength of the peak of emission would be inverse of the temperature. Stefan-Boltzmann law, on the other hand, has nothing to do with the wavelength. It says that energy is directly proportional to fourth power of temperature and energy is directly proportional to the area. To understand the Stefan-Boltzmann law, in very simple terms, what scientists have done is explain that how much power sun gives at a particular temperature. That means to understand the power of the sun, what we understand is how much power strikes the earth in a given piece of land. So in a given set of land, how much power comes from sun or how much energy comes from sun is an indicative of understanding the Stefan-Boltzmann law. Now this is how we predict that how much earth radiates in the space. So with this, since how much is coming onto the earth, we can also predict how much the earth would radiate in the space, and therefore this Stefan-Boltzmann law has nothing to do with the wavelength. It focuses on the area. So for a black body, the energy would be simply equal to the emissivity into the Stefan-Boltzmann constant multiplied by temperature raised to power 4. However, for understanding the absolute energy on a given surface, we would understand energy is equal to emissivity multiplied by the Stefan-Boltzmann constant multiplied by area into T raised to power 4. So, multiplied by the area into T raised to power 4, right? So, I have a very simple logic here. Now, since energy is directly proportional to fourth power of T, if I say temperature increases by 2 times, increase in temperature, the energy emitted would increase by 16 times. Why? Because it is 2 raised to power 4, so it becomes 16 times. Now if I say the area increases by, or the area doubles, what would be the energy emitted? What would be the impact on the energy emitted? So the energy emitted would also double in this case, because energy emitted is directly proportional to the area and directly proportional to 4 times the temperature, the fourth power of the temperature, not the 4 times, sorry, it's the fourth power of the temperature. So if the temperature increases 2 times, the energy becomes 16 times. If the area doubles, the energy doubles. If the area becomes 4 times, the energy emitted becomes 4 times. Now let me put a little complexity in the question. What if the area doubles and the temperature also doubles? Now, what would be the energy emitted? So, if the area doubles, okay, so E is equal to emissivity into Stefan-Boltzmann constant multiplied by area multiplied by temperature raised to 4th power. So, area would double, temperature would double. So, it would be 2 into 2 raised to power 4, which is 2 into 16, that is 32. That means that energy in that case would become 32 times. The emission of the energy would become 32 times. Clear? So with this we understand what is Stefan-Boltzmann law, simple numericals based on Stefan-Boltzmann law, and sometimes there are direct theoretical questions based on Stefan-Boltzmann law. All the three are extremely important laws for radiation. I repeat again, the Wien's law, Stefan-Boltzmann law and the Kirchhoff law. All of these three we have covered separately in different videos. So just check the other videos for more reference in case you have doubt. Have a wonderful day ahead.